All right. Well, good evening. It feels like it's been a while since we have done a video with you guys, but we need to get back in that habit. So tonight we're going to be talking about finding the area of shapes that are kind of combined together, and they're called composite figures. So at the top of your paper, in your journal, on your next blank page, you can write area of composite figures. Okay, so in order to do this lesson, you're going to need to refer back to the notes that we took in class today, and they should look something like this. Miss Dortick's class and Miss Gaines' class and my class, we all did the same notes. They may just look a little bit different because we're three different people, but you're going to need these area for mostly just area formulas. Those are the area formulas that I'm going to refer to. So what we're going to do first is I'm going to draw an example of a composite figure. And the first one I'm going to draw is going to look like a snow cone or an ice cream cone. Okay, so let's imagine this is a straight line. Sorry. So even if it's not a square or a rectangle or a triangle by itself, most things are made out of combining different shapes. You know that. You learned that when you were in elementary school. And the same goes for this shape. Looks like a snow cone. But if you were to divide it out, you would see that this is a semicircle, which is a half circle. And this is a triangle. Okay? So, what we need to do first is you need to find the area of this and the area of this and add them together to get the total area. That's what we're trying to do. Okay? So, let's start with the triangle first. If you look at your formula pages, it tells you that the area of a triangle is 1/2 base times height. Well, first I need to tell you what the measurements are of this snow cone shape. So this is 8 foot across. That's the diameter of the semicircle. The height, or even though it's upside down, this is still the height. The height is 7 foot. Okay. So now we can go ahead and get the area of the triangle. So the area of a triangle, I'm going to write it in a different color. The formula is 1/2 base times height. Okay. This is area of a triangle. Okay? 1/2 base times height. So now we're going to rewrite that by substituting in the different values that we know from the drawing. So I'm going to go ahead and keep the 1/2, and they're going to multiply that by the base. The base of the triangle is the flat part of the triangle, which, even though it's upside down, it's still the base, is 8. And we're going to multiply that by the height of the triangle, which is 7. That's your height. Okay? So we need to go ahead and we're going to do the multiplication first. I just put this in parentheses so you would know it's kind of off to the side and you're multiplying it by this. So you can put this in parentheses too, so you can kind of group those together. So first what you need to do is 8 times 7. 8 times 7 is 56. And then you're going to multiply that times 1/2. Well, when you do that, you have to put it in a fraction form. So you do 56 over 1. and you do 1 times top is 56. Bottom times bottom, 2 times 1 is 2. So it ends up being 56 divided by 2, and that is 28. Okay, so the triangle part area is 28. Okay, so I'm going to write that in for the triangle. The triangle is 28 square feet. So now we need to get the semicircle part. So the semicircle part, the area of a circle is pi times r squared. Okay? And since it's only half of a circle, we're going to divide that by 2. Okay? Normally it would just be pi r squared, but since we only have half the circle at the top, we have to divide it by 2. Okay? So now, let's go ahead and plug those numbers in. You have 3.14 per pi. R is the radius. Okay? The radius of the circle is not written on here specifically because this line is the width of the whole circle, the 8 feet, and that's actually the diameter. But if we know the diameter, we can get the radius because the radius is always just half of the diameter. So now we know our radius is going to be 4 feet. Okay, so I'm going to plug 4 squared. Okay, so divided by 2. Now I plugged all my numbers in, and now we're just going to do Pemdas, okay, order of operations. So these parentheses, well, it doesn't matter if you go ahead and do this times this first, or if you just square this first. I like to square this first so I can get rid of my exponent. Personally, it doesn't matter. So 4 times 4 is what this means. This means 4 times 4. This does not mean 4 times 2. It's 4 times itself. 4 times 4. So that's 16. Alright, so this is now 16 times 3.14. So over here, I'm going to do 3.14 times 16. Okay, and add them up. And then since there are 2 decimal places after, 2 numbers after the decimal place when I multiplied, I'm going to move my decimal over 2 spaces, and I get 50.24. Okay, so now I'm left with, what I just did was 3.14 times 16, and I got 50.24 divided by 2 is what I'm left with. Okay? Now, oh, sorry. Okay, I already did that. So now it's 25.12. I brought my decimal up. Okay, so this is the area of the semicircle. It's 25.12. So now I have to add the 25.12 plus the 28 to get the area of the whole figure. So you can see, you kind of have to separate all your thoughts a little bit. That's why I like using these different colors. So the last step is to do 25.12 plus 28. And you get 53.12 square feet. And that is your area of this whole figure. And all you do is you just break it into two separate figures and you find the area of each one of those and then add them together. Okay?